everyone. My name is Rebecca Bickham, editor of NACE International's Materials Performance magazine. Joining me on today's podcast are three experts from CorPro who are here to discuss corrosion-related pipeline failure. This was a driving factor behind the U.S. Department of Transportation's Pipeline and Hazardous Materials Safety Administration to publish one of the most comprehensive set of rules ever published by a regulatory agency. Because not all stakeholders and decision makers engaged in corrosion-related issues have a fundamentally sound understanding of threats to pipeline integrity, they are here to provide further insight. So my first guest is NACE member Ajay Arcari. He is a senior pipeline integrity engineer at CorPro. Hi, Ajay.
Hi, Rebecca. Thanks for having us.
Thank you for being here. Could you briefly tell us a bit about your background in pipeline integrity?
All right. I'm basically a mechanical engineer. I worked on various aspects of pipeline integrity. Some of them involve corrosion control, fitness for service evaluations, as well as mechanical testing of materials. I worked in the midstream and downstream oil and gas pipelines and facilities. Looking forward to the conversation.
Great. Thank you, Ajay. My next guest is NACE member Marlene Rodriguez. She is the operations manager of CorPro's Pipeline Direct Assessment team. Hi, Marlene.
Hey.
Could you tell us a bit about your background as well, please?
Yeah. So I've been in the corrosion control cathodic protection industry for almost, just not quite, but almost 15 years. And all 15 of those years I've been with CorPro. I'm a NACE CP3, and I started my career kind of as a junior engineer working on corrosion control and cathodic protection, and I moved into pipeline integrity, particularly ECDA, right around the time the first integrity assessment deadline was due in 2012, and have kind of been doing that ever since, and now manage the team at CorPro.
Wonderful. Thank you, Marlene. And I see here in my notes that you recently won a 2020 award as a woman worth watching in a STEM field. That's quite an honor. Congratulations.
I did. Thank you. I am incredibly honored.
And my third guest today is Dirk van Oostendorp. He is Director of Engineering and Technical Services for CorPro. Hello, Dirk.
Good afternoon, Rebecca.
Could you also tell us a little bit about your background, please?
Yes, ma'am. Thank you very much. My career spans just over 40 years now in all different areas related to pipeline integrity, corrosion control, and integrity management. Here in the United States, North America, also worldwide. Have worked in quite a few different countries, so I've had a good opportunity to see a variety of different pieces of the puzzle when it comes to pipeline integrity. And historically, we'll talk about this in just a little bit, but I was on some of the teams back in 2000, 2001, and 2002 that helped shape some of the current pipeline integrity protocols and standards that have been put together through organizations like INGA, PRCI, and AGA.
Great. Thank you, Dirk. And you're also a NACE corrosion specialist?
Yes, ma'am. NACE CP4 and corrosion specialist.
Wonderful. Okay, well, thank you all for being here. My first question for you guys is, what are the fundamental threats to pipeline integrity?
All right, this is Ajay here. I'll go first.
Okay, great.
So as Dirk mentioned, it was around the year 2000 that PRCI put together a team to analyze data from various pipeline incidents that Dirk was a part of that original team. And what they found was there were 22 different root causes which caused these incidents, which means there were 22 different threats. And all these 22 different threats were classified and grouped into 9 different categories, basically according to the nature and growth mechanisms of the threats. And these 9 were further grouped and classified into 3 categories, mainly based on time-related defect types. So at a high level, threats are basically classified into 3 areas. The first one being the time dependent, the second one is time independent, and the third one is resident defects. And time-dependent threats are external corrosion, internal corrosion, stress corrosion, cracking. The time-independent threats, we have third-party damage, mechanical damage, incurred operations, and weather-related. And resident defects are manufacturing defects such as defective seam or defective pipe, welding or fabrication-related defects such as girth weld, defective pipe, girth weld, or wrinkle bend, and those things. And equipment-related defects, such as mechanical seals in a pump or O-rings or a relief valve, and those things. So there are 22 different threats. But what's interesting to know is PHMSA releases an annual incident report. And the top 2 incidents, almost always that are reported, are third-party interference as well as corrosion. And these two are exponentially higher than any other threat. Third-party interference, for example, you have a utility pipeline company excavating and accidentally hitting the pipeline. Corrosion is more predictable. It's not as random as third-party. It's more easily manageable. But these two are by far the 2 most important incidents than any other threat. So that's an important thing to know.
All right. And what do you all think are the most important aspects of corrosion management?
Rebecca, this is Dirk.
Sure.
So pipeline integrity as we know it changed back in 1999 on a afternoon in June in 1999. A number of different conditions all converged to cause a pipeline failure and leak and subsequent explosion in Bellingham, Washington. From that point forward, there was a need to change the entire view on pipeline safety because there were casualties involved in that case. It was a pipeline leak that involved a spill. And then just as these headlines were starting to gather support through the regulatory agencies, a second incident occurred in August 2000 in Carlsbad, New Mexico, involving a natural gas pipeline that also resulted in casualties. So this forced the hand on the regulatory side with the Department of Transportation through what was the Office of Pipeline Safety at that time, and that has now become the PHMSA organization, to prioritize reviews and changes to the regulations as far as how operators are going to have to approach the integrity of the pipelines, the management of the integrity of the pipelines, and the pipeline safety. Prior to that, there was a much more reactive approach to pipeline management. The changes that took place in the federal regulations drove this to a more proactive program and a forward-thinking program, also more descriptive. It involved pipeline operators having to put together a pipeline integrity plan, their playbook as to how they're going to identify the threats, both internally and externally to their pipelines, risk assessments of those pipelines, and then their sort of cyclical inspection integrity assessment programs that they're going to be using for data gathering and making plans for repairs or further remedial efforts on these aging pipeline structures. So I think that's a historical perspective of where it all started. There have been subsequent updates to the regulations, and some of the states have also put some of their own regulations in to deal with more local conditions. So I think that gives a very good historical context as to what's changed. And I think Marlene can provide quite a bit more on the current status as to what's going on.
If you ask me what's the most important aspect of corrosion management, I mean, obviously there's kind of what's prescriptive, what's prescribed, and what's required, and that's understanding your corrosion threat or just what your pipeline integrity threat is, and then and then assessing the risk of that and how it affects whatever risk model you want to run, but how it affects the environment and people and all that stuff, and those are big aspects of it. And the one that that really comes to mind to me, if you were to ask me, what's the most important aspect, what comes to mind is data, and having good data and accurate data, and being able to validate that data, and then having educated, trained individuals that can analyze that data and help you validate it and tell you if it's good, and making sure that you have competent people that can demonstrate that.
All right. Oh, sorry. Go ahead, Ajay.
Just to add to what Marlene said, the big companies, they sit on a mountain of data right now, right? But we need good data and quality data, as Marlene said, and operators have made a lot of strides over the last few years to collect more and better data, but there are several gaps that still exist, and that is one of the challenges, definitely.
Okay, thank you all. That's great information. My next question is, how do pipeline operators integrate best practices into existing operations?
This is Ajay here again. So there's a wide spectrum here. It depends on how many technicians the operator has and how much training needs to be given. And as Dirk called it the other day, the ouch level. It depends on the operator. You have some operators who don't want any accidents or incidents on their pipeline system, and they'll do everything they possibly can to keep them safe. And there are others who calculate the amount of risk and see what's the chance something's going to happen, and then decide how much it's going to cost, and they probably will live with it. So it really depends on where they set the ouch level, as Dirk put it.
One thing I would add too, and it's something that's kind of coming up, becoming more and more important, is your GIS platform, and utilizing that information to house all your data. And one thing we had talked about the other day was machine learning, and using machine learning to kind of help you predict it and help you analyze what's going on, and then also to integrate your best practices and then apply that everywhere, and maybe not just in one specific location.
Yeah, thanks, Marlene. GIS platforms are becoming a large part of the whole data management process, because once again, if we think about technology and where it's developed in the years, large data is becoming a real fact, and many of the companies are now going to interactive GIS platforms where the data then can get projected out onto, something along the lines of a Google Earth format and a false background to actually see where the data aligns in space. The data now also is time date stamped and position stamped for accuracy from compliance standpoint, and this allows multiple data sets to be overlaid on top of each other, in a virtual setting for real live analytics and trending analysis as to how things are progressing between the different surveys or inspections that are being done. Technology's really advanced, so many of these systems these platforms are being moved to a cloud-based infrastructure, which allows much more rapid access for people. It's now possible for field technicians to be able to access this information even on a smartphone or a tablet, be able to pull this data, query this data, and look at it. There are also some very interesting things that have been done in recent years using virtual reality. And as machine learning is now starting to take place, but with virtual reality, being able to review data in the virtual sense, view that and be able to interpret it from there. And then machine learning is definitely going to be the next piece that's coming into the game, where each time a system processes data, it learns from that data. It learns to get better and faster in the processing and analysis piece. So I think in the next 3 to 5 years, we're going to see some substantial movement in that space. And the connectivity between the information being gathered at the field level, being linked up through the cloud, through wireless communication systems, back into these databases for processing and recycling back, is going to cut down the amount of time from an interrogation being done through the analysis phase to a decision being made. And so all of those pieces are definitely going to improve the turnaround time on that, and being able to respond to, potential hazards and threats faster, I think is a great trend to the future.
Just to add to what Dirk mentioned on machine learning, the tech industry already has made enormous leaps in machine learning. Google, Facebook, Netflix, and those companies. But the pipeline industry is more critical. But we definitely will get there pretty soon. But it's more critical because the pipeline industry is more. We measure. It's not just the cost. It's in terms of human life as well. So even if Netflix pushes suggests you a wrong movie, or Facebook pushes you a wrong advertisement, I think that's okay. But if we want to use machine learning to make some crucial decisions in the pipeline industry, we need to have the model really validated. But we are not far away from doing it. At the end of the day, machine learning will be one of the tools at our disposal, and it depends on how we are going to use it.
Wonderful. Thank you all. That was really interesting. My final question for you all today is, how do integrity programs meet compliance requirements?
This Ajay here. So since 2002, every pipeline operator needs to have a written pipeline integrity management plan. We have CFR, the code for federal regulations 192 and 195 for gas pipelines and liquid pipelines. And these regulations, that's a law, right? They're federal regulations, it's a law. The regulations, they set requirements, but they also provide guidance on preventive and mitigative measures, establish time frames, and for upgrades and repairs and so on. But as the minimum, the operator needs to include some basic information, and some of the information that needs to be contained in this manual are what the process for identifying which pipeline segments are HCAs, for example, which depend on the number of buildings, or occupancy, waterways, etc. It needs to specify what the training requirements need to be. And as Dirk mentioned, since last fall, we have the mega rule that's put in place. So now we have moderate consequence areas as well, in addition to high consequence areas, and that needs to be incorporated into the manual as well.
Yeah, thank you, AJ. Taking that one slight step further as well. So the regulations were put in place as a result of the pipeline accidents and have evolved since then. The pipeline integrity management plan that the operators have is their playbook that states how they're going to handle the threats. To support that, organizations like NACE have been very actively involved, along with others like ASME and API, to develop peer-reviewed standards that have now become a part of the guidance documents as to how you would implement different pieces of this. The federal regulations will set the bounds as to what's acceptable and what their expectations are, and then on the implementation phase, the operators can call on some of these technical groups as well for information to support that program. So, for example, NACE has several documents on the direct assessment tools and processes that are available, that are reviewed on an ongoing basis, improved as new technologies develop or as more things have been learned, and that's a support piece to it from a compliance standpoint. And the other piece is, as we mentioned earlier, there's operator qualification requirements that the Department of Transportation has set so that you make sure there are competent people actually performing these tasks. And so each of the operators has a defined set of operator qualifications, OQs, that the people performing these different tasks will need to have trained and demonstrated competencies in. So there's a suite of information and a suite of tools available that support them in the implementation of their integrity programs.
Okay, great. Well, thank you all so much to our experts, Ajay, Marlene, and Dirk from CorPro for joining me today. If our listeners want to learn more, what is your website that they can go to, the CorPro website?
It would be at www.agion.com, and at the Agion website, there is the corrosion protection platform, which CorPro is a part of, and inside of the corrosion protection platform, there will be a number of different links to the different pieces about the parts of the business, the services that we provide, and references there to contact.
Wonderful, thank you. So this is where we'll end things today. Again, my name is Rebecca Bickham, editor of Materials Performance Magazine. Thanks for listening.